Hello everyone, I'm Dr. Srashta Chowdhury from the Department of Geography, Salesian College Autonomous, Siliguri. Today, of all the four spheres of the Earth, that is the Geosphere, Hydrosphere, Biosphere and the Atmosphere, we are going to do the vertical structure of the atmosphere on the basis of temperature difference. What is the atmosphere? It is a thin and shallow blanket of air which not only provides us the necessary air we breathe in but also protects us from the harmful radiation of the sun. The atmosphere begins at the Earth's surface and extends upwards. However, the question is, where does the atmosphere end and where does the outer space begin? There is no such sharp boundary that is existent, but studies have revealed that the temperature change in the air vertically has been conducted, and by the early 20th century, the atmosphere was already divided vertically into 5 different layers on the basis of temperature. So accordingly, we have the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. Now, each of these layers have distinct characteristics of their own. The troposphere, which is the lowest layer of the Earth's atmosphere, the term was coined by a meteorologist named Tesserine D. Bott. It extends from 8 to 18 kilometers. It is different at the equator and at the poles. At the equator, it extends from 16 to 18 kilometers, and at the poles, it extends till 8 kilometers. Now, during the summer season at the equator, the extent of the troposphere is still 18 kilometers, whereas during the winter times, it extends till 16 kilometers. This is due to the temperature differences or the insolation that the equator receives in the different times of the season. In the troposphere, it is also seen there is an environmental lapse rate, which means that there is a decrease in temperature with increase in altitude, and the rate of this decrease of temperature with increase in altitude is 6.5 degrees Celsius per kilometer. The troposphere also is the chief focus of the meteorologists because in this layer all the phenomena take place. It is also called the zone of mixing. Every cloud formation, the cyclones, the storms and precipitation, it takes place in this layer. So this layer is also called the troposphere. The boundary between the troposphere and the next layer is called the tropopause. This is the layer, the tropopause is the layer where all the mixing stop. Before the tropopause starts, the temperature in the troposphere drops to minus 60 degrees Celsius. At the tropopause, there is no real change in the temperature. The next layer is the stratosphere. The lower layer of the stratosphere is isothermal in nature. That means there is no real change in temperature as the altitude increases. But in between 10 to 30 kilometers of the stratosphere, it is seen that there is an increase in temperature. This is also called the inversion of temperature, where the temperature increases with increase in height. This increase in temperature beyond 10 kilometers is because of the presence of the ozone layer in the stratosphere. The temperature increases in this layer because the ozone layer absorbs the harmful UV rays from the sun. The maximum ozone concentration, it is actually between 50 and 30 kilometers, but the inversion of temperature goes on till the stratopause because there are small amounts of ozone above this height range, which also keeps absorbing the UV energy and the temperatures rise. The air is stable in this layer and the aircraft often fly through this layer to avoid any kind of turbulence. Beyond this where stratosphere ends is the stratopause. After the stratopause is the mesosphere. The mesosphere is again the layer where there is a decrease in temperature with increase in height. The extension of the mesosphere is from 50 to 85 kilometers, and it is one of the coldest layers. In the mesopause, the temperature approaches to minus 90 degrees Celsius, which is lowest in the atmosphere. The pressure is lowest in this layer, and therefore it is inaccessible by airplanes or research balloons or satellites, as a result of which very less is known about this layer. The next is the mesopause, where the transition of temperature again stops, and beyond that is the thermosphere, which extends from 85 to 500 kilometers. Here the temperature increases sharply with altitude and can exceed 1000 degrees Celsius. What is the major characteristic of this layer? This layer, it contains only a fraction of the atmosphere's mass, and in the extremely rarefied air of this outermost layer, temperature again increases. So basically we get to see inversion of temperature in this layer as well. The thermosphere is divided into two layers, that is the ionosphere and the exosphere. The ionosphere is one of the major reason why we see the northern lights or the aurora australis and the aurora borealis in the skies. The ionosphere, it is a region in the earth's atmosphere which is again divided into different layers. The D layer, which extends from 60 to 99 kilometer, the E layer, which extends from 90 to 130 kilometer and is also known as the Kennelly heaviside layer. The F layer, which is also known as the Appleton layer and is divided into two, that is the F1 and the F2 layer, and the G layer, which is 400 kilometers and above. The special characteristics of each of these layers are that the D layer, it is only active during the daytime. As the sun sets, the D layer, it vanishes. Similar with the F layer, the F1 and the F2 layer is only active during the daytime, whereas as the sun sets, it merges into only the F layer. Then is the exosphere, which is the outermost layer, then is the outermost layer of the atmosphere, which is the exosphere, and it starts from 500 kilometer. 500 kilometer, it gradually fades into the outer space. This is a very thin layer of air and satellites orbit here. The density of atoms at such height in the atmosphere is low, as a result of which, despite the temperatures being high, you cannot feel the temperature. The kinetic temperature at this height, it goes up to 5568 degree Celsius. Other than the vertical structure of the atmosphere being studied on the basis of temperature, we can also study the vertical structure of the atmosphere on the basis of its composition and divide it into the heterosphere and the homosphere. Thank you.